one in polynomials, lesson 5, and we're going to start writing equations. Alright, so page 23 is where we're going to pick up it. This is kind of fun. Again, well, I say it's fun. It should be finally tying everything together with polynomials, equations, expressions, or whatnot. So now we know how to find every root. We know how to find every factor. Now let's write as complicated equations as we want to, given any kind of root. Okay. Now before we can just go in and start writing stuff, first thing we need to do is make sure none are missing. Okay. So we need to write all missing roots. Now 9 times out of 10 you're not going to have to write any. But when you do, or like you may wonder, how do you know if a root is missing? A root is missing if you have an I or a radical sign. Okay? If you have an I or a radical sign, you have missing roots. Okay? If not, you can just proceed straight to step 2, and you're just going to change roots to factors. Alright, so before I get too ahead of myself, let's go through here, and I'm going to do the first one, and I'm going to do the first one, second one, and I'm going to start on the third one. I'm not going to work all the way through it, however. Alright, so write all missing roots if there are any ones that are missing. So do I have an I? Do I have a square root for any of my roots listed? No. Do I have an I? Do I have a square root for any of my roots listed? And I do. Okay. There. Now, the way you write a missing root, okay, is you just take the opposite sign. Alright. Here's the 3 square root of 2 is positive, so I need to add a negative 3 square root of 2. In the bottom, do I have an I? Do I have a square root? If so, I have to write the opposite sign. If not, I'm good. So I have negative 4, and then I have a 3 minus 2i. So this term right here, or this root, has an I in it, so I must take the sign opposite of what I have. Now, this right here, what I'm doing is wrong. Okay? The reason it's wrong is I only need to take the sign opposite that's in front of the number attached to I, or the addition or subtraction that's in front of the I. Reason this is, it goes back to quadratic formula, the negative b plus or minus square root. Remember, our I comes from when our square root is negative, so this is where plus minus is. Alright, so this is no good, but this is very good. So again, you only want to change the sign that's in front of the number attached to the I, or just the sign in front of the I by itself. Second thing what we're going to do, we're going to change all roots to factors. Again, the way you do that is just simply change the sign. Okay, so negative 5 is going to be x plus 5. X plus 8, or positive 8, will just be x minus 8. Here, it'll be x plus 8, x minus 2. Then I have x minus 3 square root 2. Then on the last one, it's x plus 3 square root 2. On bottom, x plus 4, x minus 3, okay, plus 2i, and then x minus 3 minus 2i. Alright, moving on back here. After you change all your roots to factors, you're going to multiply all of your factors. And then simplify. Okay. From here, it's math 1, math 2, maybe in a little bit of middle grade stuff. So I'm not going to go through the second one, the third one. I'm just going to go through the first one. Okay. So I have, you know what? I lied. I'll leave this one and the third one. I'll do the second one. When I have more than just 2, I like to just do these in pairs. Reason I do them in pairs is because I can essentially almost do the box method in my head. Alright, so I can have x times x is x squared, first outside minus 2x plus 8x minus 16, and I essentially talk myself through it there, going pretty slow. And then here, if you do these enough, right, when I was in school, my teacher would give me like 50 of these, and either you did them or you didn't do them. If you didn't do them, well, y'all know what happens. So you get really good at doing this stuff pretty mentally, and test makers know this, okay? So the reason we give you stuff like this is so that you can make a mistake, a simple mistake, and it's going to cause you to get the entire problem wrong. So I would advise you to slow down, take the time to write the stuff, or write everything down so you can go back and check your work if your answer winds up being wrong. Okay, x squared minus 18, x squared 6x minus 6 minus 16. Alright, and once I get into having to multiply, you know, anything bigger than like a 2 by 2 box, I have to write it down. Alright, x4 minus 18x squared plus 6x cubed, 18 times 6, 108. It's a negative 108x minus 16x squared, negative 16 times negative 18. It's 288. From here, I combine like terms. Again, highest degree to lowest degree. X to the fourth plus 6x cubed minus 34x squared minus 108x plus 288. Now, my last step that I don't have here, because a bunch of us will not take the time to do, and this is where we'll miss it, especially if it's a free response, it's because we won't take the time to go back and verify. Alright, I'm going to tell you to verify using your calculator, and again, calculator needs to be in A plus BI mode. Alright, and then this will just allow me to use the both positive, or imaginary and real solutions along with irrational ones. The reason I don't like Desmos for this is, one, it won't do imaginary roots or solutions, nor will it give you perfect, exact, precise real solutions that are irrational. Okay, so like the decimals, it may round them, which will not appear on your answer, or that's going to be another reason, you know, you'll get the question wrong because it'll be some rounding error. Test makers know this. So verify your work, verify answers given by using a calculator, A plus BI mode. And again, the way we do this is store X, enter, and all of this is doing is essentially evaluating. Alright, we need our result to be 0. If it's not 0, it's wrong. Go to the next answer choice or go back and look at your work. Okay. And again, all we do is plug in the roots. -8, store x enter. We then type our polynomial, x to the 4th, plus 6x cubed, minus 34x squared, minus 108x, plus 288. I hit enter, and I get 0. So, -8 is good. 2, store x, enter. Instead of taking such a long time to type your entire polynomial back in, if you arrow up, it will highlight it. Once it highlights it, hit enter, and then enter again. Okay. Gives me 0. So we're still good. Now, I need to type 3 square root 2, and again, I check all of these. If one is wrong, then all of them, then the entire thing is wrong. So 3 square root of 2 is good. -3 square root of 2, store x, enter. Make sure when you're doing radical numbers, or a radical, that you arrow to the right to get the STO with the arrow outside or outside of being underneath the radical. Okay. And again, go back up, highlight polynomial, enter, and I get 0. All of my roots and solutions give me 0, so therefore I know I did it correctly. Alright. I'm going to give you quick answer choices. Which of these is right for this example, A, B, or C? Do that so just put A, B, or C, click A, B, C in your play pause it video. Okay. So, moving on to page 24. This page should actually be easier than the other one. What we're going to do, again, I want us to get very good at seeing if we're missing any roots. If we're missing them, let's write them down. Okay. So, in number 9, am I missing any roots? Again, thought process 4, if I'm missing any roots. If it has what 2 things, then I'm missing stuff. Radical or I. Okay? A radical symbol or an I. I'm missing an I, or I have an I, then I'm missing. What's my missing root right here? It's going to be 1 plus 2i. For number 10, am I missing any roots? Yes or no? I'm not, because I don't have a radical symbol or a root with I in it. Okay. 12, 13, 14, 16, 17 we've already done. Okay. I just want to talk about very briefly what we're doing. Lowest degree possible means, right, that so the polynomial with the lowest amount of roots, and I could add more and it wouldn't be wrong, but this one is the only one that tells us. Okay. For number 15, this is going to trick up a bunch of y'all on your final exam. It's going to trick up a bunch of you when it talks about, it's going to give you a polynomial, it's going to tell you to graph it, and then it's going to trick you because of the way the polynomial acts. Okay? And I'll explain a little bit of that in a couple of minutes. So, polynomial that has a root at 2 with a multiplicity of 3. Alright? When you see this word multiplicity, it resembles the word multiply. Okay? When you multiply things, okay, if I have, multiple students in my room, or if I have a bag of Skittles and I have multiples of one color, it means that I have more than just one. Okay? 2 with the multiplicity of 3. 2 is my root with a multiplicity of 3 is just how many. Okay? So, this is saying that 2 is a root 3 times. Alright? So if I want to write a polynomial, I can just, again, what's my process? Change roots to factors. Alright? And then multiply. So, if you don't see this, okay, this is your right answer. Alright? This is going to be on your test as an answer choice. This right here will probably also be on your test as an answer choice again. X minus 2x minus 2, x squared minus 4x plus 4, x cubed minus 4x squared plus 4x minus 2x squared minus 8x, so plus 8x minus 8. A bunch of you are going to get this here and say, or you're going to raise your hand and say, well, the correct answer is not up there. Okay, what strategy have we looked at when you want to know if two polynomials, two algebraic expressions are equivalent? Graphs overlap. Okay, so x minus 2, this is what I have. This is what I want to test to see if they are equivalent. If they overlap, then they're equivalent. Okay. Now, also another thing you're going to see from this red graph when we get into multiplicity is the graph, it doesn't go through. Okay. When it gets to 2, it's like it touches it. Okay. A better example of this is x minus 2 squared. Okay. So it bounces and it changes direction. Okay. So if you have a factor, or if you have a polynomial in parentheses raised to a power, that power tells you how many times or how many number of roots is at this particular factor. Okay. Now, don't get this confused with x to the 4th power minus 2x squared plus 9. Okay. Let's go minus 9. Reason being is you don't want to say, ooh, 4. So it's got 4 roots. No. Parentheses, okay? Terms or factors in parentheses raised to a power. That's the only time you have multiple. This tells you how many. Alright? So if you look at this quadratic, now this is where knowing the fundamental theorem of algebra comes in, because you can say, oh, this polynomial, right, most of you, what you would do is you would take and multiply it and you would see it's an x squared. Do that, you'll never get it wrong. But you can say, oh, it's got a degree of 2, therefore I know it has 2 solutions. Now, what are they? Well, I only see 2. So the way you would answer this is there's 2 solutions. The solution is 2, but it occurs twice. Okay, so this is what multiplicity means, and that's about it for today. If try a couple other questions. If you have, questions about them, shoot me an email, and I'll make another video going maybe over a couple of these, or number 11.